So our final topic in this section is about the position vector for a projectile. So we're going to start with our formula for the position vector of a projectile. The formula says neglecting air resistance the path of a projectile launched from an initial height h with initial speed v0 and angle of elevation theta is described by the following vector valued function r of t. It's v0 cosine theta ti plus h plus v0 sine theta t minus 1/2 gt squared j, where g is the acceleration due to gravity. So we're going to look at an example of a projectile motion problem. So let's say a baseball is hit 3 feet above ground level at 100 feet per second and an angle of 45 degrees with respect to the ground. Find the maximum height reached by the ball, by the baseball. That's the first thing. Second thing, will it clear a 10-foot high fence located 300 feet from home plate? So let's break down all the information we were given. They gave us the h, the initial height. H was 3. They gave us the initial velocity, v0. It was 100 feet per second. I'll just write 100 here. They gave us theta, the angle of elevation. It was 45 degrees or really pi over 4. And then here, I'm working in feet per second. So G, in that case, would be 32 feet per second squared. So let's plug this all into our formula for projectile motion. R of t, it's 100 cosine pi over 4 ti plus h was 3 plus 100 sine pi over 4 t minus a half of 32 is 16, 16t squared j. So I'm getting 50 square root of 2 ti plus 3 plus 50 square root of 2t minus 16t squared j. So then I'm going to take the derivative of my position vector, r prime of t, and that'll give me velocity. So 50 square root of 2i plus 50 square root of 2 minus 32t j. Now I want to know the maximum height, which means I need to look at my y-coordinate here. Y-coordinate here. So to get the maximum height, you set your y prime that we found, which was 50 square root of 2 minus 32t, set that equal to 0 and solve for t. So if you solve for t here, you'll get 25 square roots of 2 over 16. And if you need a decimal approximation for this, t is approximately 2.21 seconds. But that wasn't really what I was asked for. I was asked for the actual height. What is the maximum height reached, not when does the maximum height occur. So in order to find, again, the maximum height, you're going to plug this value of t here into your r function, but really only into the y-coordinate part. So go back to your y equation. Y was 3 plus 50 square roots of 2t minus 16t squared, and you're going to plug in your fraction there. 25 square roots of 2 over 16 minus 16, 25 square roots of 2 over 16 squared. And if you simplify all this stuff, you'll get y equals 649 over 8, or y is approximately 81 feet. So that is the maximum height that was reached. So we answered the first part of the question, but the second part of the question is, will it clear a 10-foot high fence located 300 feet away? So the first thing we need to know is, at what time is the ball going to hit the 300-foot fence? So I'm going to set x of t equal to 300, because the fence is 300 feet away. X of t is 50 square roots of 2t. So if you solve for t here, you're going to get that t is up 3 over the square root of 2, which is approximately 4.24 seconds. And so now I need to know, okay, it reaches the fence, but how high is it at that moment? So you're going to plug this time into your x equation. So your y equation. Y was 3 plus minus 16t squared. Plug in that value, and we'll see what height is it when it reaches the fence. So 3 plus 50 square roots of 2 minus 16 times. So it looks like you're getting 303 minus 288, so it'll be 15 feet. So when it reaches the fence, it's at 15 feet. But remember, the fence is only 10 feet. So yes, it cleared the 10-foot fence. The ball clears the 10-foot fence for a home run.